Welcome to this second video on Poisson distribution. Theoretical distributions can be broadly classified as discrete and continuous distribution, and under theoretical distribution discrete case we are seeing about binomial and Poisson. Poisson is practically applicable to cases when the number of trials are more in the sense when n is going to be greater than 20. So we will try applying them to few problems. If the probability of a bad reaction from a certain injection is 0.001, what is the probability that out of 2000 individuals, more than 2 will get a bad reaction? Say if this is going to be the nature of question, do you find any word like binomial or Poisson over here? No. So it has no direct implication that this problem is following a binomial or this problem is going to follow a Poisson. Hence, we need to take the clues which are available over here in this question and decide what distribution we need to apply. So, we have been given with certain data. What are the data? The probability of the reaction has been given as 0.01. And secondly, we have more than 2000 individuals are going to be administered for this injection. So taking or acting on these clues, then we can say that we have been given probability P equal to 0.001 and N is equal to 2000. 2000 individuals are taken for giving the injection. Now this data provides the required information that we will be following Poisson distribution. Why? So we know that when N is going to be greater than 20, then we move on to apply Poisson distribution. So we take these clues, and furthermore we know the limiting cases of binomial to Poisson as P tends to infinity. This is our second clue to validate that this is going to follow a Poisson distribution. So as the chances of success becomes very small, it is going to be rarely happening action, then you apply Poisson distribution. Now we have two clues to say that this is going to follow Poisson distribution more clearly. Now what is going to be the definition or the probability mass function for the Poisson? It is given by e power minus lambda power x by x factorial, valid for x varying from 0, 1, 2 up to infinity. So the only thing which is required over here to fix the Poisson distribution is the parameter called as lambda, but we know no information about your lambda over here, but we know from the limiting case that lambda is equal to np. So this is going to be quite a important thing for us to use, apply and then get the answer. So we know that lambda equal to np, n is going to be equal to 2000. So this 2000 can be multiplied with your P, which is going to be 0.001, and hence you find the value of lambda to be equal to 2. Now this helps us fix the remaining of the quantity. The known parameter lambda is 2 for the given problem. The question asks us, what is the probability that more than 2 individuals will get a bad reaction? So if we denote, say x is going to be the number of individuals who are going to get the bad reaction, then probability of x more than 2, so it is greater than 2. This is the question we have been asked to find for. We know that x varies from 0, 1, 2 up to infinity. So we need to compute from 2 to infinity. Practically this is going to be impossible. So what we can do is go for the complement of it. What is the complement of it? So it is 1 minus probability of x less than or equal to 2. A caution over here, whenever you have a strict greater inequality, the complement must contain a equality. When you have 2 not included, include it over here in the complement. So if 2 has been included here, ignore it, because every number has to be counted exactly once for its probability. So now going for it, what are the numbers which are going to be less than or equal to 2? So it is 1 minus probability that x equal to 0, probability of x equal to 1 plus probability of x equal to 2. So this has to be now evaluated and then put over here. So this is going to be equal to 1 minus e to the power of minus lambda. What is lambda? 2. So this 2 can be taken outside. So 2 to the power of 0 by 0 factorial, 2 to the power of 1 by 1 factorial, 2 to the power of 2 divided by 2 factorial. This is in one way which you can evaluate. Otherwise, you can effectively use your calculator, just key in the data. So what will be the quantity will be, you can go for e power, so e will be got using your shift and log. So you will have e and then go for power, then input minus 2, and then you can go with a multiplication sign, and then you can go for 2, rise it to the power of x. X is input as alpha times of x, so you will have your capital X, and then a division, and then you need a x factorial. So use your shift and your x inverse. If you use your shift and x inverse, then this will replace it with x factorial. Use your calculator option or the button to get the values for your 0, 1 and 2. Get the input, subtract it from the quantity 1, or you can just estimate the value of e power minus 2. Anything power 0 is going to be equal to 1. So this is going to be 1 by 0 factorial is 1. 2 divided by 1 factorial is 1. 2 square is going to be 4 by 2 factorial is 2. So this also can be estimated with e power minus 2 and then subtracted from 1 to get the final answer. So the final answer will be 0.323. Check if you're getting this value. Moving on now to the next question. Problem number 2. The proof of a 500-page book contains 500 misprints. Find the probability that there are at least 4 misprints in a randomly chosen page. Just like our prior problem, we don't find any keywords like binomial or Poisson appearing over here. So we will take the clues from the question and then fix what distribution the problem follows. So you say you are turning a book which contains 500 pages. The number of pages is going to be equal to 500. And what is going to be the number of misprints in each of the pages? The book total number of pages, number of misprints. Number of misprints is going to be equal to 500. So n equal to 500, which is greater than 20. Now says that this is going to follow what distribution? Poisson distribution. So the clue appears as the number of pages. So it follows Poisson distribution. What's the probability function for the Poisson distribution? X equal to e power minus lambda, lambda power x by x factorial, valid for x varying from 0, 1, 2 up to infinity. Now the task is to find lambda. What is going to be lambda? Lambda is the parameter of the distribution. Lambda is the mean of the distribution. Lambda is the variance of the distribution. So that's the speciality of Poisson. So Poisson has parameter, mean, variance, all of them to be the same. So now we have the data that out of 500 pages there are going to be 500 misprints. So what is going to be the average number of misprints? So misprints will now be equal to the number of misprints by the number of pages. So what is going to be the number of misprints? Number of misprints is going to be 500 and number of pages is going to be also 500. So that makes it as 1. So this average number of misprints is going to be your lambda now, because average denotes the mean of the random variable. So we have lambda to be equal to 1. So in a disguised manner we have been given the data, and so from the data we abstract the quantity which is required for us. Now going into the question, find the probability that there are at least 4 misprints. At least meaning 4 or more than 4. Number of misprints is your random variable x, so you want at least 4. So 4 or more than 4. So practically we will be moving from 4 to infinity. So this is going to be a really impossible task. So we move on with our complement, going for probability of x strictly less than 4. So notice when I take the complement, when you have a greater than or equal to included over here, the complement will be strictly less than. So you will have to include the equality only in one side of your equation. If it is present here, ignore here. If it is ignored here, present it here. So the number of values over here will be 1 minus probability of x equal to 0, x equal to 1, x equal to 2, x equal to 3. We are not including 4 because it is strictly less than 4. So it is 1 minus, what is common to all of them? E to the power of minus 1 is common to all of them. So you will have 1 to the power of 0 by 0 factorial, 1 to the power of 1 by 1 factorial, 1 to the power of 2 by 2 factorial, and 1 to the power of 3 by 3 factorial. So you can estimate it by making use of the value e power minus 1. So you can take this as 1 minus e power minus 1, 0.3679, and so 1, you have 1 power 0 is anything power 0 is 1, and 0 factorial is 1. 1 plus 1, 1 plus 1, and 1 by 2 factorial is 2, 3 factorial is 6. So this is going to be equal to 1 plus 1 plus, this is going to be 1 by 2 plus 1 by 6, because 3 factorial is nothing but 1 into 2 into 3. So this is going to be equal to 6. If you are not able to get it manually, use your factorial button in your calculator. It is present on top of your x inverse button. So use your shift and then get your x factorial, which is present in yellow color over here. So this will give me the value of 1 minus the data as 0.01886. So this is going to be my final answer. So the probability of finding at least 4 misprints in a randomly chosen page is going to be 0.01886.